I wanted to do a follow-up from last week's video. So last week's video talked about how you might calculate pi, or more importantly, how you probably wouldn't calculate pi by counting pixels on a screen. And that method was I drew a circle on the screen in VGA mode, just the outline of a circle, and then swept through the circle and counted all of the pixels that made up the outline. And so if the pixel was black, it gets set to blue, and if the pixel was white, it gets set to a bright white. And for that way, I'm able to count up all the pixels that make up the outline of the circle with the simple assumption, actually it turns out to be the very naive assumption, that pixel count might be the circumference. But that actually doesn't work. In the video that I mentioned last week, I said that the error was because you're really sampling the circle, not actually drawing the outline of a circle. That actually is not correct. And actually, I'm going to link in the video description to a very well done video from 3 Blue 1 Brown about why that method doesn't work. It's the second of the false proofs that he goes through, demonstrating the limit of a sequence of curves to estimate the circumference of a circle. But there's actually a better way to calculate pi by counting pixels on the screen. And this was suggested in the comments last week, and so I wanted to show it off. So let's go ahead and copy pi.c, and we're going to make a new program called area.c, because we're going to calculate pi by counting pixels that make up the area of a circle. So let's go ahead and edit area.c. So this is the program that we had last week. What I'm going to do is down here where we drew the ellipse, we used gborder last time, and that is the macro that says we're going to only draw an outline of the circle, not filling in the circle. But we actually want to fill in the circle this time. So instead of gborder, we're going to use gfill interior, and that will create a circle that has been completely filled in, and that circle is goes from 0, 0 to 479, 479. Now at the end of the program where we report the values is where we need to make the other change. And so before we were saying the pixel count was probably an estimate of the circumference, but now since we've filled in the circle using that gfill interior, the pixel count is now the area. And the diameter, of course, is still 480, and in fact the radius is 240. And that's important because to calculate area of a circle, area is pi r squared, or in other words, pi is area pi is the area divided by r squared. And so that's what I'm going to do on this last output line. It's going to be pi is the area divided by r squared. And so here count is now the area of the circle. It's all the pixels that make up the interior of the circle. And then I'm going to replace this 480 with 240 times 240. And that's the radius squared. And so now I can go ahead and save and quit. And I can compile the new program with the Watcom compiler and linker. We'll do it with -q so that way it's not as chatty when it compiles. And there's area.c. I'm not seeing any errors, so now we can go ahead and run area. And so there we've got a completely filled in circle, and the same function that we did last time is going on now. So any black pixels get turned into blue, and any white pixels get turned into a bright white, and that way we know our progress. And at the end, it's now done a new pixel count of the area of the circle. We know what the diameter is, of course we know then what the radius is, and pi is the area divided by the square of the radius, or 3.14. So we actually got really much closer to the defining pi by counting pixels in a circle. So I just wanted to share that. That was a comment that somebody had made in last week's video, and I just wanted to share the updated video here. So what did you think about this video? Let me know in the comments below. Before I go, I just wanted to thank everybody who supports me on Patreon. You really do make this channel happen, and I thank every one of you for your support there. Some of you are sponsoring me at a higher level, and I want to thank you again, especially here for that. Visit our website at FreeDOS.org, join us on Facebook, follow us on Mastodon, and consider supporting me on Patreon. Thank you.